Hello, George Romanic here. In my video on the Compton generator, we had this integral over there that we needed to solve, and I said I will solve it in separate videos so that that video is not too long. By the way, Compton generator is a simple apparatus that can be used to demonstrate that the Earth is rotating, and it can be used to demonstrate therefore the existence of the Coriolis force, Coriolis effect. So if you want, I suggest you go and check that video if you're interested in that physical process. The question is, how do we solve this integral in this video? And that's a relatively simple integral to solve. You remember that solution is pi. I already told you in the separate video that solution is pi, so if you are just interested in solution, that's the end of this video. But how do we get this? Well, we use trigonometric identities to solve this integral sine squared theta d theta in the limits between 0 and 2 pi. And the trigonometric identity in question is that sine squared theta is equal 1 minus cosine 2 theta divided by 2. Now some of you are looking at this and saying, okay, go ahead, continue, but I would assume that many of you say, but how can I know this trigonometric identity? There are a few options. Option number one, you don't, and that's it. Option number two is you memorize it. Nothing wrong with that. And option number three, you know how to derive it from other trigonometric identities, and that's what I will demonstrate here. So to get this trigonometric identity, let's do that here. You start by the basic trigonometric identity that sine square theta plus cosine square theta is equal to 1. If you don't know this one, then close this video and go and read some basic books on trigonometry, because it doesn't get more basic than this. This is in fact called fundamental trigonometric identity. So from here you can see that sine square theta is equal 1 minus cosine square theta. Okay, but now what is cosine 2 theta? So let's call this equation number 1. And we will use it later. What is cosine 2 theta? Cosine 2 theta is equal cosine theta plus theta. Theta plus theta is 2 theta. But this is further equal. Let's continue here. Well, this is cosine of the sum of two angles. So that will be cosine of the first angle, which is theta, times cosine of the second angle, which is again theta, minus sine of the first angle, sine of the second angle. And look, this is cosine squared theta minus sine squared theta. Or from this equation, you can see that cosine squared theta is equal cosine 2 theta minus, or rather plus, sorry, sine 2 theta, sine squared theta. Okay? So let's call this equation number 2. And now look, I can plug equation number 2 in equation number 1 over here to get what? Well, to get that sine squared theta is equal 1 minus cosine squared theta. That will be cosine 2 theta plus sine square theta. Or that is further equal 1 minus cosine 2 theta minus sine square theta. Or from here, when I move this to that side over there, I will get 2 sine square theta, which means that sine square theta is equal 1 minus cosine 2 theta divided by 2. And this is exactly that formula over there. I hope you can recognize that. Okay, but this is just proof of this formula. So how do we use now this formula to solve this integral? Well, now it becomes very simple. So we say that integral I is equal integral 0 to 2 pi. Instead of sine square theta, I write 1 minus cosine 2 theta over 2 d theta. And this is further equal, now I split this integral into two integrals. Integral from 0 to 2 pi d theta half minus integral 0 to 2 pi cosine 2 theta over 2 d theta. And this is further equal, well, this is theta in the limits 0 to 2 pi, so I will have 1 over 2 pi minus 0. That's the solution of this integral. And minus 1 over 2 integral 0 to 2 pi cosine 2 theta d theta. Well, 2 and 2 cancels, so this only becomes pi. Okay, let's continue here. So I is equal pi minus now what do we have here? Well, here, how do we solve this integral? That's very simple. We introduce substitution that 2 theta is some k. And that means that 2 d theta is equal dk. Okay? And therefore, that integral over there is minus 1 over 2 integral cosine 2 theta, but 2 theta is k, and that d theta is dk over 2, dk over 2, and we have limits. What are the limits? Well, when theta is 0, k is 0. When theta is 2 pi, k is 4 pi. So this goes from 0 to 4 pi. And now this is further equal pi minus 1 over 2 integral of cosine, rather 1 over 4 because of these two. Integral of cosine is sine of k, and that goes in the limits between 0 to 4 pi. But you should know that sine of 4 pi is 0, and sine of 0 is also 0, which means that this integral over here is 0. Sine of the upper limit is 0, sine of the lower limit is 0, this is 0. Which means only this term survives, and that term is pi, which means that this integral I is pi. Which is exactly what I wrote here, and this is how you solve this type of integral, and hopefully that can help you in trigonometry, mathematics of integrals, as well as my video on the Compton generator. Until next video, goodbye.